My name's William Gray. I'm a research scientist and I split my time currently between the York Biomedical Research Institute in York and the Francis Crick Institute here in London. My current project focuses on the way that proteins work within our cells. So whether it be the production, the degradation, the modification, how it changes their function, where they're located, and really how this impacts the function of a cell. And specifically, I'm interested in how this is hijacked during transformation of the blood system to form leukemia. My primary focus is on acute myeloid leukemia, or AML. In the poorest prognostic cases, AML has been estimated to have a 5 to 15% overall survival, so that could be as low as 1 in 20 people survive up to 2 years. So that really is a dismal prognosis across cancer. Within that, there's a really specific subset called acute promyelocytic leukemia, or APL, and that was one of the first cancers to have a targeted therapy, and you have in the high 90s of a survival. So what we know from that is that we can find really very specific ways within specific diseases to take something from 1 in 20 surviving through to really could be 19 in 20 surviving. This will make a difference to patients through kind of 2 key outcomes. The first is how specifically to target these leukemic cells that are important for maintaining the disease, for drug resistance, for relapse, so all the reasons that patients might die. On top of that, everybody will have seen chemotherapy patients who have these horrendous side toxicities. They lose their hair, they can get horrible infections and illnesses, and they have really bad sort of gut digestion problems. Part of the research is also focused on how to mitigate those off-target effects. And if we think about mitigating off-target effects, we also think about some of the older patients, people who are not really eligible for really intensive chemotherapy. They have a really poor outcome because they can't be treated particularly well. So if we can bring them back into the eligibility criteria, we can give them more effective therapies. My hope for the future is that we push really hard on developing technology, we push really hard on developing biology, and if we can really get them in line together, we can go towards somewhere where we do have personalised medicine, quite specific to somebody's disease, and that's always going to work better. Personally, I'm hoping to sort of open into a broad research program understanding the underlying biology of the disease. So why does a normal cell become cancerous? And in leukemia, this is really, really important because if we can't discriminate between the two, we might be able to clear all of your leukemia, but then we essentially clear all of your healthy blood as well. Without your healthy blood, you're not going to live. So my sort of broader view for the future is to be able to really better understand the difference between what is healthy and what is not healthy in our blood system. The John Goldman Fellowship, for the immediate future, it means I can take some of these hypotheses that I've come up with and test them in a real world scenario of saying, does a combination of therapies targeted versus X, Y, and Z really make a clear difference to the leukemia? And does it really protect the normal healthy stem cell systems in your body? In the long term, it's allowed me to establish my own independent group at the York Biomedical Research Institute, and I'll be surrounded by some world-class haematologists as well as oncologists and people really across fields of science. So it's a really exciting thing for me.